All right, so number one, it says m plus 3 equals negative 16. These are going to say solve and check. What do we do to start getting m by itself? First of all, you got to ask yourself, is it simplified? Is it? Yep. So what do we do, Chase? So subtract 3 on both sides. These cancel out. I'm left with m is equal to, what do I do on this side? Sam? Yes, are you going to make sure you do that, Samuel? Yep. What do we get? Negative 19. Okay, we're going to stick it back up in there for m. We're going to write negative 19 plus 3. What is negative 19 plus 3? Negative 16, is that what we wanted? Yep, that's what we wanted right here. Checks. Number 2. All right, let's look at this one. It is simplified, so we don't have to do anything else. They're subtracting 7, so we're going to add 7 to both sides. Okay. X minus 7 plus 7, they cancel out, leaving me with x is equal to 5. Check it by putting it back into the original problem. 5 minus 7. I got to keep change opposite. What's 5 plus negative 7? Negative 2. Is that what I wanted? Yep. All right, on this one, what does it mean when negative 8 is sitting next to x? Multiply. So we're going to undo multiplication by? We're going to divide both sides by? Nope. What's the number out in front? Negative 8. If you don't show what you're doing to both sides and using the same number, it's going to be wrong. So negative 32 divided by negative 8 gives you a positive what? 4. How do we know if we're right? Check it. We're going to plug it right back in for x. Negative 8 times 4. What is that? Negative 32. Is that what we wanted? Yep, and it checks. Look at this one. Notice that m is being, what does that line mean? Divided by negative 4. What undoes division? We're going to multiply both sides by the same number they divided by, which is negative 4. Positive times negative is? So we get negative 44 equals m. I'm going to check it by plugging it right back in there for m. Negative 44 divided by negative 4. Negative divided by negative is a? 44 divided by 4? 11. All right, looks like you guys have a lot of good answers. Can you simplify anything? No. So put your wall up. We're going to undo adding or subtracting first. So we're going to subtract 7 on both sides. Right? These cancel out, leaving me with 4x equals 32. We're still not done, are we? They're multiplying by 4 with the x, so we're going to both sides by 4. So x is going to equal 8. A lot of you had the right answer. How do we know if we're right? Plug it right back in there. 4 times 8 plus 7. What do we want that to equal? 39. This is an order of operations problem in your check. What do we do first? Add or multiply? 4 times 8 is 32 plus 7. What is that? 39. Is that what we wanted? And it checks. There's nothing we can simplify here, right? So they are adding 10 to x divided by 6. So we're going to subtract 10 on both sides. And we get x divided by 6 equals 5. We still don't have x by itself. It's still not isolated. They are dividing by 6, so we are going to multiply both sides by 6. Remember, this 6 is in the numerator, this one's in the denominator, so they cancel, leaving me with x is equal to 30. A lot of good answers I saw. Put it back up into the problem. 10 plus 30 divided by 6. What do I want that to equal? 15. Do I add or divide first? 30 divided by 5 is, or 6 is 5, and we get 15, and it checks. A lot of not right answers. So, can we do what's in the parentheses? No. Okay, so what are we going to use on this? The distributive property. So here we get 3x minus, here we get 12 equals negative 18. Can we combine 3x minus 12? They're not like terms. So we now undo the order of operations. They're subtracting 12. We're going to add 12. How many of you did keep change opposite on the original problem? Did you still end up adding 12 to both sides? Yes. Because subtracting a negative 12 is the same as adding the 12. Here we get 3x equals negative 18 plus 12. You are really subtracting those. 18 minus 12 is 6. Keep the sign of the 18, which is negative. We're not done yet. They are multiplying 3 by x, so we're going to divide both sides by 3. And x is going to equal negative 2. Plug it back in up at the very beginning. Negative 2 up there at the beginning. So we're going to go 3 times the quantity. Negative 2 minus 4. I want that to equal negative 18. This is an order of operations problem now. Do what is inside the parentheses first, but we have to keep change opposite in here. So what is negative 2 plus negative 4?
6.
What?
6.
What? Negative 6. What's 3 times negative 6? Negative 18. Is that what we wanted?
Yeah.
Check. And on the test with the story problem, you are going to need to define a variable, write an equation, and solve it algebraically. So I'm going to read to you a problem that you're going to be doing. Types of problem. It costs $4 to enter the fair. Each ride costs $2.50. You have $21.50. How many rides can you go on? It costs $4 to enter the fair. Each ride costs $2.50. You have $21.50. How many rides can you go on? How are we going to define the variable in this problem? What is unknown here? Raise your hand and tell me what's unknown, Bailey. Give me a variable, Bailey. R? R equals the number of rides. You have to define the variable. I'm the reader. You have to do that. What does it automatically cost me just to get into the fair? Is that going to change depending on how many rides I go on? That's a flat fee, isn't it? $4?
Yeah.
And then I want to go on rides. So what's that going to do to that cost? It's going to make it go up. So it's adding. How much is it per ride? Because each ride is $2.50. That's called a unit rate. If I go on 3 rides, what would I do? I would take $2.50 times 3. If I went on 6 rides, I'd take $2.50 times 6. If I go on R rides, I'd take 250 times R. And that is equal to $21.50. That's all I have to spend. So go ahead and solve that one. What's the first thing that I need to do to start solving? They are adding 4, so we're going to subtract 4 on both sides. Where's the decimal point in number 4? At the very end. So we got to subtract. Those cancel. We get $2.50. R equals, what's 21.50 minus 4? 17.50. What do we do now to get R by itself? Chase? Yep. All right, guys, a little suggestion for you. You see this part right here? 1750 divided by 250. Can't I just mark off these 2 and zeros? Can't I? Now, when I put 17 or 17.5 under here and 2.5 on the outside, can I divide like that? No. Move the decimal point over once on each one. And then I always ask myself, how many 25s are in $1.75? How many 25 cents are in 175 cents? And the answer is 7, and that's perfectly, right? Just because it's a decimal problem doesn't mean it has to be hard. So R is going to equal 7, and then look at how you defined your variable. 7 what? Rides.
Would you actually write let R, or could you just
Yep.
write R?